Alright, let's get started here with 12.1, Systems of Linear Equations. We're going to do substitution and elimination. So this is something you've definitely seen in Algebra 1 before. We'll do a quick review here. And if you are fine with substitution and elimination, go ahead and skip straight to the more advanced video, and we're going to be doing 3 variables there. So we're going to start here, review lesson with 2 variables. So we've got a movie theater selling tickets for $9 each. So let's go 9x there. And we're selling tickets to seniors, not seniors in high school, probably seniors as in over 55 or 60, but maybe seniors in high school get a discount. 7y there, they're getting a discount of 2, so they're getting sold for $7. We're making $4,760. There we go. There's a nice equation. Problem here is that we've got 2 variables, an x and a y. To solve 2 variables, we need 2 equations. So let's go down here and see what our second equation would be. We know 600 tickets were sold. Between x and y, how would we write an equation? Well, if we added up x and y together, that would be all of the tickets. So that'd be 600. So there we go. 2 equations for 2 variables. And we'd be ready to solve this. All right. So here's some examples of some equations. The first problem you're going to do here, 9, is just making sure that any value that's given works for a system of equations. So if I told you here for C that x equals 2, y equals 3, and z equals 1, does this work for the system of equations? Let's check. In equation 1, that's what this 1 is saying over here, we have 2 plus y is 3 plus z is 1. Does that equal 6? Yes, it does. It works. Does that work for the entire system of equations, though? We need to check for all of them. So let's check here. Is 3 times 2 minus 2 times 3 plus 4 times 1 equal to 9? Let's see here. 6 minus 6, that's 0, plus 4? No, not equal to 9. So these would not be a solution for our system of equations. All right, so check problem 9, see if the values they give you are a solution for the system that they present. All right, let's take a look at some possibilities here for a system of equations. We have a solution and just one solution if we have 2 lines that cross each other, that intersect each other, and they cross at a point of intersection. A system is consistent if it has a solution, so this is consistent. And if there's only one, if they cross in one spot, it's independent. So if we have one solution, we have consistency, and we're independent. What about if we never touch each other? Then we would not have a solution. We have no solution, so we are inconsistent. Lastly, we could be consistent, but have 2 lines lying right on top of each other. And so these would be consistent, but they're dependent, meaning that you don't have one point of intersection, you have infinitely many points of intersection. All right, so let's go ahead and find 3 different ways to solve these equations. The first one we're going to do is graphically. Let me grab my graphing calculator. And what I've done is I've already popped into my y equals these 2 equations. Now you have to get y by itself, so I moved y over and I moved the 13 over, 2x minus 13. Same thing here, I moved the y over, so it's positive, negative 4x minus 7 divided by 9. I've got my 2 equations. I go to graph them, and they're crossing here. So this is going to be consistent. All right, it's independent. There's one solution. What is it? Let's let the calculator calculate it for us. So we hit second, trace. There's our calculate. We're going to find the intersection. So number 5. All right, first curve. We just need to hit enter when the cursor's on one of the lines. There it is. Enter. Is the cursor on the second curve? Sure. And now what's our guess? Where do they cross? Right about there is my best guess. So my solution here is 5, negative 3. If we checked this, is 2 times 5 minus negative 3 equal to 13? 10 plus 3? Absolutely. Is negative 4 times 5 minus 9 times negative 3 equal to 7? Well, is negative 20 plus 27 equal to 7? Absolutely also. Alright, so now that we know how to do it graphically, let's try substitution to see if we can get this without using a graph. Alright, so substitution, what we're going to do is get one variable by itself, y equals 2x minus 13. And then we're going to take that y and plug it in wherever we see y in the other equation. So minus 4x minus 9 times 2x minus 13, substituting in, equals 7. Negative 4x minus 18x plus 117 equals 7. So negative 22x equals negative 110. X equals, you guessed it, 5. That's what we got from the graph. Plug it back in up here. Y equals 2 times 5. That's 10 minus 13. Y equals negative 3. So our answer again is 5 comma negative 3. Alright, pause the video, try problem 19, and try to solve problem 19 using substitution. Substitution only. Okay, now we're going to try elimination. So elimination, here's the steps. You've seen this before. This is the one where we line up our variables. So x on top of x, y on top of y. And we need to multiply the equation so one of the variables' coefficients lines up. So I'm going to get the y's to match up. I'm going to times this by 24. Because 24 divided by 8 gives me 3. So let's rewrite this equation. 24 divided by 2 is 12. Times 3 is 36x plus 24 divided by 8 is 3y equals negative, not 1. Don't forget to multiply that last one. That's a common mistake. Negative 24 there. 16x plus 3y equals negative 28. Notice I multiplied the bottom equation by just 1. I left it alone because our y's already match up. If we subtract straight down, we'll have 20x equals, if you minus a negative, you're adding. So x equals 0.2, 4 over 20, 1/5. Let's go ahead and plug back in. I like this equation. Don't want to deal with the fractions there. 16 times 0.2 plus 3y equals negative 28. Alright, so this is 3.2 plus 3y equals negative 28. I'm going to minus that 3.2 to have 3y equal negative 31.2. And if I divide, I end up with negative 10.4. Alright, so our final answer here is, and that's equal to y, 0.2 comma negative 10.4. If we weren't sure, we could always graph it. Graph both equations. Use the intersects feature to check to see if we're correct. Alright, go back in there, try problem 19 using elimination this time. Alright, lastly here, let's see if we can set up our movie theater example here and solve it using either substitution or elimination. So we had 9x plus 7y equals 4760. And we had x plus y equals 600. Let's go ahead and multiply this second equation by 9, so our x's match up. 9x plus 7y equals 4760 is the first equation. 9x plus 9y equals 5400 is the second equation. And so when we subtract down, we're going to have, what do we have here? Negative 640. I believe that's right. 48, yep. Equals, the x's will cancel, negative 2y. Divide by negative 2, y equals 320. 320 seniors are going to the show. How many regular tickets did we sell? Let's plug it back in here. We've got x plus 320 equals 600. Subtract that 320 and x is going to be 280. So, final solution, 280, comma, 320. Okay, so I'm going to pause the video here and create a separate video starting with objective 3, where we're going to start talking about inconsistent dependent two variable equations, and then we'll do 3 variable equations as well.